This is one of the most crucial components to the modular lighting rig I've started selling, and despite the fact that it looks like a fairly simple part, manufacturing these has become a major bottleneck, preventing me from getting orders out the door quickly. So in this video, I'm going to show you how I built this device that has cut my manufacturing time for this part down by 90% while simultaneously saving me thousands of dollars. So this component, we'll call it a contact spring, is what provides the electrical connection between the proprietary socket I designed that sits inside of this spool base here, and the fixtures, which have these plugs with 4 protruding screws. The point of this socket is to allow anyone to design a custom light fixture, and as long as the fixture has a plug like this, the fixtures will work with the system. When the plug is inserted into the socket, these spring contacts, which are soldered onto the spool's cable that connects to the brain, should make contact with these screws, completing the circuit. And when these contacts are manufactured properly, you should see them move slightly as the screws engage with them, and ideally there should be an audible and satisfying click when the fixture is inserted. Unfortunately, up until this point, each one of these spring contacts had to be handmade, which was tedious and took forever, but this also meant that getting the tolerance right for each one of the 32 contacts needed for each full lighting rig was difficult to do, and they often required some post-assembly tweaking to fine-tune them. I knew this was going to have to change, and as a result, I designed this. But to really explain what an arduous process this was and why I decided to go this route, I need to jump back a couple years to when I released my first video on YouTube about the original DIY lighting rig that started this whole journey. I had just moved to a new town, and all of my tools and partially completed projects were still packed away in boxes in the garage. But for some reason I decided that I had to start a YouTube channel ASAP. And I had this light rig I built a few years prior that I had brought on a few tours with me, and I figured I'd make a video about that since it was already built. And sure enough, people seemed to like the video. In fact, many of you liked it so much that the request to make the rig available for purchase couldn't be ignored. But this original version, made out of plumbing parts and styrofoam and wood, didn't seem like something worth selling, but I still felt compelled to try and make it something that anyone could have. So I released a tutorial on how to build it, and many of you have done so, and that is so cool to me. But still, people wanted the rig without having to make a million trips to Home Depot, which I totally understand. And during this time, I connected with my now business partners, Andy and Austin, and we decided to give this whole thing a go for real. So I designed a new system, taking notes from all the comments I had received and adding all the features I could, and released the Pedal Rig version 2 video, which featured a prototype of the rig that we are now manufacturing in Texas. One of the main goals of the new design was to include as many off-the-shelf components that we could, and we kept the design open source so anyone could build any aspect of this rig that they wanted. But for all the custom components, we were set on using readily available rapid manufacturing techniques so that as we started rolling this out, we could order small quantities of these custom components without having to invest a ton of money into tooling and committing to massive quantity orders. And I think we've accomplished this with the use of 3D printing our own plastic pieces and using third-party laser cutting services for all the aluminum and acrylic parts. But there was one component that I could never work into our supply chain in the same way, and that part was the contact spring. I tried searching for weeks to incorporate an off-the-shelf spring into the new socket design that I could buy in whatever quantity we needed, but there was nothing out there that I could find that ticked all the boxes. And a big part of designing the new system was to be cross-compatible with the original design so that had you built the original rig already, you could use the same fixtures from that rig on a new V2 rig if you ever decided to upgrade. In the original design, I used these tent pole springs that I modified by cutting, bending, and puncturing them, and at the time discovering these was actually my favorite breakthrough. I remember going through this whole process back then of searching through potential options for these contact springs, and when I found these, it was a total light bulb moment. The great thing about these tent pole springs is they are super common and extremely affordable while also having a good amount of spring to them. And they were easy to solder to as well. I actually tried a bunch of different things, from binder clips to window screen springs, and the tent pole springs were the only thing that fulfilled every single requirement. I also really liked having these buttons on the end that could be used as an indexing point for installing them onto the socket, as well as a really nice place to solder the wires to. So these tent pole springs were a total success. So much so that we've continued using them in the new design, but the way we've been making them was not working for us at all. Let me show you. In order to modify these springs, I start by cutting them in half with a set of tin snips, which is relatively easy. And then I had to add a hole for the wire, which I originally did by drilling until I discovered using a sharp center punch and a hammer to be much quicker. It's a little less clean of a hole, but that really doesn't matter here. But then came the bending step, and this is where things got really tough when we needed to make hundreds of these. Basically, all I've been doing is using a set of pliers to bend them by hand, trying my best to keep the bend locations as identical as I could across all the contacts. I did eventually evolve into using this random metal V-groove thingy that I could press a bar into that would give me a generally accurate shape, but this still wasn't ideal. Clearly, this isn't a reliable method, and as a result, I had to spend time to check every individual contact during this bending process by temporarily placing them in the socket and making sure the fixture plug would engage with them. On top of this, after about 10 contacts, my fingers start to really hate me. These aren't physically that hard to bend, but the sharp edges and the small size made this a painfully tedious process. So I wanted to make a jig that could help me get more repeatable bends, and my initial thought was to use a board with some slats at various depths that I could insert the springs in, and with some sort of marker I could make sure I was bending each contact the exact same amount. Now, because these contacts require more than one bend each, I'd need multiple board slots, and I'd have to carry the contact through a series of bending steps to get to the final shape. But then I had a thought. What if I could create a device that could achieve all of the bends simultaneously? And then I thought, if I'm going to go that far, why not make it cut and puncture the contacts at the same time? A device that could do all of these steps simultaneously would be a massive time saver and could change the trajectory of this component from being a real headache to something that I can mass produce in relatively large quantities with ease. Now, what I was planning was nothing new. In fact, manufacturers have been doing this kind of thing for decades, and in the manufacturing world, what I wanted to build was called a compound die. You see, pretty much every metal component, from pieces like this all the way up to the huge panels that make up your car, are made using a giant machine called a punch press. These tools are essentially just massive hammers that can apply enough force down on a custom mold called a die that has been carefully designed and machined to take a blank ribbon of metal and stamp it into the desired shape. These punch presses are super cool, and I've always wanted one, but they are a bit on the pricier side and generally are way too massive to put in my shop. But what I do have is an arbor press. Ugh. This little guy here is deceptively heavy, and with the crank of this handle, it can apply 1 ton of force down on this single point. Because the part I'm making is fairly small, I was pretty confident that 1 ton of force would be enough to form, puncture, and cut my part all in one go. Now, the actual punch press machines are pretty cool, but they're fairly simple machines. The real fascinating aspect of this manufacturing technique is the stamping die that goes inside of them. Each die, usually comprised of a bottom and top mold in its most basic form, has to be carefully engineered for each individual part you want to make. Think of them like a really expensive cookie cutter. As a ribbon of material is fed through the die, the punch comes out and can cut or form the piece you want. If you have a piece that requires multiple cutting or forming steps, or a combination of these, there are 2 main types of dies you'll need to consider. A progressive die, which you can think of as a row of cookie cutters all lined up sequentially, works so that when the ribbon of raw material is pulled through, every punch of the press will take the ribbon through an individual processing step. The part has to be designed to remain attached to the ribbon of material throughout this process until that final stage where the last punch will remove it from the ribbon. These progressive dies are a thing of beauty, and I hope one day I have a reason to have one made for me, but there's another type of die that will work better for what I'm planning right now, and it's called a compound die. Unlike the progressive die that breaks up the forming and cutting into multiple steps to achieve far more complex parts, the compound die seeks to do all the steps at once. Something like making a washer is technically considered a compound die as it makes 2 cuts at a time, one for the center hole and one for the outer circle. But I think a better example is a locking washer that has a split in it and requires an additional bending step that happens all at once. Compound dies seem a lot simpler than progressive dies, but because they do more at once, they are limited to how complex the final parts can be. But luckily for me, my part is probably simple enough to make use of this method. Now you're probably thinking, if manufacturers have been making parts like this for so long, surely you could have a legit manufacturer make these parts for you, right? Well, that's what I thought until I started asking around. The thing is, even for simple parts like mine, the process of having a custom die designed and manufactured is understandably incredibly expensive. From the research I've done, it'd probably be in the area of about $10,000 roughly, just to have the tool made. And on top of this, most companies won't even entertain the idea of this unless you plan on making massive quantity orders, which in my case would be in the 100,000 units or more range. This is the big drawback to this type of manufacturing process. While the per unit prices can be as low as possible thanks to the fairly hands-off and speedy manufacturing, the setup itself is not speedy or hands-off at all. So this is the crux of my situation and why I thought I could build my own little punch press operation by designing my very own compound die and printing it out of ABS. So I started by tackling the hardest part first, the bending. I basically wanted to try and mimic the method I was using with the metal V thingy I had, but instead of pressing the part down with my hand, I just attached the bar to the arbor press and have at it. So I created some bottom test molds and just used my hand like I originally was to see if these molds could get me close to the shape I wanted. But I was finding the bar I was using, which was just a flathead screwdriver that I ground to a blunt point, had to sort of slide and pivot along the mold to create something even slightly resembling the shape I wanted. And I thought that trying to mount this bar onto the arbor press in a way that could slide and pivot like this was going to be difficult. But as I got to my 6th test mold, I noticed how well the solid ABS prints were holding up to the pressure, and so I decided to try to also print the top half of the mold by just duplicating and inverting the shape and leaving a little bit of room for my part to fit in between. And boy, did this work well. In fact, this worked so well that it made me rethink some things. With this method, I could not only mimic the hand-bent contact shapes, I could potentially add some additional features to the bends that would improve the user experience of the sockets a lot. Basically, the ideal contact would have a little bump at around this spot that would provide a really satisfying click when inserting the fixture. This would be nearly impossible to do by hand, but wouldn't be that difficult to do using this new 3D printed method. So I carried on with iterating, and on version 13, I got this. Isn't that nice? And this satisfying click is the result of this tiny little feature here that would be way too tedious to do by hand. One interesting thing I found throughout this process is in my iterations right before this final one, the bump feature I added was much more pronounced and worked really well individually, but when working together in a socket with 3 other contacts, that bump was way too much for the socket. So I had to really pull back on this bump feature until it was almost non-existent. So this tiny little bend here is the perfect amount that will get that great click. So with the bending aspect of the die mostly figured out, I designed a housing for the bender to sit inside that had rails to guide the top half of the die perfectly into the bottom half. I wanted to avoid printing the bending portion of the die directly into the housing so that if I ever needed to make any tweaks to the design, I could just reprint these little sections instead of having to reprint the entire thing. This should also let me quickly reprint this small portion of the die when they inevitably start to wear out from repeated use. While I was designing the housing, I started working on adding the cutting and puncturing aspect of the jig. For the puncturing side, it was as simple as just including a hole that I could slide my pointy center punch into, and that worked pretty much immediately. But the cutting side proved to be a little more difficult than I had originally thought. I wanted to use a modified chisel as the top blade along with a metal edge as the bottom blade, basically reconstructing a mini guillotine. But I live in a small town with minimal access to raw materials, and while the chisels would be easy to find, I didn't really see anything in the stores that could be easily modified to make the bottom blade. And I was also concerned that I wouldn't be able to get the tolerances tight enough to make the cut. Using some paper and this pair of old scissors to demonstrate, And I know you've all experienced this before. When these blades get loose over time, they allow a big enough gap between the blades to form that the paper can just bend into instead of being sheared. But you can fix this by just simply using your hands to apply some pressure in a way that closes the gap between these blades so that the paper has nowhere to go and is forced to shear along the cut. The really nice thing about scissors is, since the blades are always in contact with each other, even when the blades are in their opened position, provided there is a reasonable amount of force holding the blades together, the blades will always guide themselves throughout the cut. Now, in my original plan with the chisel, because the blade would be so short, meaning the chisel would have to separate from the bottom blade entirely to make enough room to get the tent pole spring in there, I'd have to figure out a different way to make sure that the top of the blade was perfectly in line with the bottom of the blade throughout the cut, because if it was too loose, I'd fail to cut my part, just like the pair of old scissors. But if it was too tight, the blade would likely just run into the bottom blade as opposed to passing by it perfectly. And I just felt like getting this to run smoothly over repeated use of the tool could be a bit too hard to achieve with a 3D printed die. So I basically wanted to pivot from the chisel idea and find something that had this perfect cutting tolerance baked in. Then I realized the tin snips I was using already were exactly what I needed. So I bought a new pair of snips and cut off the unnecessary components until I had this. And then it was just a matter of designing, printing, testing, modifying, and reprinting until I had a part that fit perfectly. With everything figured out, I just had to assemble the final jig with some springs and fasteners and give it a go. I have the small metal plate that sits on top of the jig, which I think helps distribute the single small point of the arbor press over the whole top surface of my die. And I have a similar plate, just a little bit thicker for the bottom as well. So now I can really show you how this thing is supposed to work. As I crank on the arbor press, you can see this nub here starts to press down on the blade, which will cut the tent pole spring first. Once the cut is complete, the bending part can start to form the metal, and the center punch can dive into the button here to puncture the hole. The tent pole spring just sits with the button inserted in this hole here, and this little ledge makes sure the spring is sitting straight in the jig. So it's honestly pretty simple overall, and for the most part, I was able to get this full assembly working on the first go. However, initially I struggled to get the tent pole spring to sit in the die nicely, as every time the blade came down, due to the shape of the original tent pole spring, the blade would want to push the spring out of position and fail. I thought I could design some sort of spring-loaded holding mechanism into the die that would hold down the button side until the cutting step was completed. But in a stroke of luck, one of my test bending forms had the indexing holes for the button of the spring slightly undersized enough that I could press the button into it firmly, which would hold the spring in place tight enough to make a successful stamping. This does mean that once the stamping is complete, I have to use a pry to manually remove the finished part, which is definitely a step I'd like to remove in a revised version of this tool one day, but honestly, the simplicity of this current setup makes this additional step totally worth it for now. So now I want to show you just how effective this tool is. Each full lighting rig comes with 8 of these spool bases, and each base has one socket containing 4 contacts. Meaning each order requires me to make 32 contacts. So I wanted to make a set of contacts using the handmade method first, before switching to the new arbor press method, and then compare the total manufacturing time for each, as well as a quality control check. So let's get the timer going and see how we do. keep breaking them. I'm going too fast. Gotta be a little more careful. Okay, done. Kind of. 22, 23, 24, 25, 26, 27. I broke 4 of them, so let me do this one last one. Oh, I broke that one too. Okay, I broke 5 of them. Okay, let's inspect our work here. These are the handmade ones, and I managed to get 32 of them done in about 28 minutes, or just under half an hour. I had 5 casualties, which isn't that big of a deal, but they shouldn't be breaking. And that's just me not being careful. Now, 28 minutes is really quick for this. I've timed this before when I was actually making them for people, and took me about an hour per set on average. Obviously being way more careful. You know, these are pretty drastically different. And you'll notice too when I show you the contacts that come off the arbor press, these are quite a different shape. And that's because when I was making these ones, I wasn't able to get so accurate that I could do these perfect shapes. So these are overbent. Almost all of them are overbent, which was necessary when I was making these by hand. This probably took, I probably did this about twice as fast as I normally would. The quality, I think, shows. The fact that I broke 5 of them, it was also a factor. And I haven't tested most of these on a socket. I'm pretty sure they would work, but you know, this is just me trying to go as quick as possible. So these aren't really up to snuff anyways. But let's move on over to the arbor press and see what we can get away with there. Now we're going to do the arbor press method.
This arbor press is the best. I wouldn't have guessed that I'd be so damn impressed with it. I might be obsessed with it. This arbor press is so fine, with the voice of its own. I can press all my parts with one punch, I can press all my parts with one punch.
And time. Okay, so these were the handmade ones, and these are the arbor pressed ones. And as you can see, the consistency is much better, I would say. This took only, 7 minutes to make? And I don't have to test these as I'm making them. I could just solder these right on and test them at the very end. And I'm pretty sure they would all function properly. Now you can I can't focus enough, but you can see the tiniest little bend where the bump is that creates that click. It's so subtle, it almost looks like a mistake on these, but they all have it, and that's exactly what we need to make them operate the way that I want them to. So I think that's a pretty good success. And then just looking back at the handmade ones again, like look how crazy different these ones are. These two, you know, so the bends kind of happen at different spots. And then back to these again, and these, if you look at the buttons, they're all pretty much identical where the buttons are. So this is obviously a very niche solution to a very specific problem, but in today's world where manufacturing locally seems to be the goal for many businesses, I hope this project can inspire some of you to consider some alternative methods to traditional manufacturing. Next time you're faced with a massive quote for tooling a simple part like this, maybe all you really need is a 3D printed jig and an arbor press to get the job done. Thanks so much for watching, and I'll catch you in the next video.